Hi everyone. In this video clip, I'm going to share with you some of the high order thinking questions in Form 3, Chapter 1, Indices. Now, before we start, we need to recall on the important formula in this chapter. So let's start. The first law of indices will be the law on to the product, a to the power of m times a to the power of n. Okay, we will get a to the power of m plus n. When we have the same base with different index and it has to be a multiplication, then we add the index. The second law of indices will be a to the power of m divided by a to the power of n, or sometimes you see the question write a to the power of m over a to the power of n. Both mean the same thing, so it will give us a to the power of m minus n. Okay, the third one, we will have a to the power of m, b to the power of n, all right, raised up to the power of p. So we will have a to the power of mp, b to the power of np. Okay, this is the multiplication. What if we have the division? Same thing, when everything raised up to the power of p, we will have a to the power of mp over b to the power of np. And the most important part, a to the power of negative n, the negative index, we can write it in a positive index by changing the position of the base from the numerator to denominator or vice versa. Okay, so with this law of indices in mind, then we can solve our question. Now the rules of thumb that is always change the index number in the smallest base. Okay, choose to rewrite this in the smallest base. So 27 can be written in 3 to the power of 3. And then raise up to the power of 1 over 3. The original index, we still have not used it, so we got to copy. The rest divided by 9. We can change the 9 to 3 squared. Okay, again, the original index, we still have not used it, so copy it. 3 over 2 equals to x squared. All right, now let's open up the bracket. We have 3 to the power of 1 divided 3 to the power of 3 equals to x squared. Now always make our subject on the left-hand side. So let me rewrite x squared on the left-hand side. And on the right-hand side, 3 to the power of 1 minus the index 3. So we will have 3 to the power of negative 2. Change this into the positive index. So we will have 1 over 3 raised up to the power of 2, which is 1 over 9. And this is x squared. What we want is x, not x squared. So we have to bring the square root across to the other side. So the moment we change, okay, we change squared to the other side of the equation, we have to put plus and minus in front. Okay, why? Because we know that negative 2, when we squared, we get 4. Positive 2, when we squared, we also get 4. So now if I have x squared equals to 4, what can my x be? My x can be both positive and negative 2, isn't it? So remember the rules of when we change the square across to the other side of the equation, we have to put plus minus in front of our inverse of the square, which is square root. Okay, so that is the rules. Yeah, remember this. And therefore, we will have plus minus 1 over 3 as our answer. After all, the questions say, find the values of x. So we will have more than one value of x. Okay, so that is the question number 1. Let's move on to the next question. Okay, for this question, We are given 5 to the power of 3y minus 1 equals to 5 to the power of 2y. Bracket means multiply. Now, at the same time, remember I said always change the number in index form with the smallest base that we can think of. So 25 is actually 5 squared. Okay, so that we can apply the law of indices, where when it is multiplied, we can just add the index. So 2y plus 2 on the right-hand side, whereby on the left-hand side still remain as 3y minus 1. So now we have the same base on both sides. Therefore, the index must be the same. So 3y minus 1 equals to 2y plus 2. Okay, this is just a normal algebraic expression, algebraic equation. So let's rearrange so that we can put the y on the left-hand side and the number will be gathered on the right-hand side. So we have 2 plus 1. So 3y minus 2y left with 1y. So 2 plus 1 is 3. So that is the answer. Okay, so you see that I always change the number in the index form with the smallest space that I can think of. Now, number three, we need to find the values, we have to find the value of A in this equation. So we have 9 to the power 1 over 2. Now, since every number are in base 9, shall we just leave our this number in the index form with base 9. You want to change to base 2 also can, no issue. All right, let's try to maintain the base as 9, okay? So we have 9 to the power of 1 over A equals 2. Now, multiply the index in this equation. So we have 9 to the power of 2 times with 4 over 5. All right, times 9 to the power of half times 4 over 5. Okay, divided by 9 to the power of, multiply this in 7 over 2 times 3. Yeah? So we have 20, okay, let me just write like this, 7 over 2 times 3 times 9 to the power of negative 3 times 3. Okay, then we simplify the index. So we have 9 to the power of 8 over 5. It's multiplied, so we plus. Over here, we will have simplified this. Okay, so we will have 2 over 5. And then divided by, solve whatever inside this square bracket, 9 to the power of 21 over 2. It's multiplied, so we plus the index, which is negative 9. Okay, plus a negative 9 give us minus 9. So over here, we have 9 to the power of, same denominator, we just add the numerator. So 8 plus 2 is 10. Okay, divided by this one, 21 over 2 minus 9. We can use the calculator or we find the lowest common multiple, which is 2. All right, then we have 9 to the power of 10 over 5 is 2. And then minus this one, 21 minus 18. So we have 3 over 2. So 9 to the power of 1 over A equals to 9 to the power of 2 minus 3 over 2. Same base. Now we can equalize the index. So let me put it here. So we have 1 over A equals to 2 minus 3 over 2. So let's find the lowest common multiple, which is 2. So over here we get 4. 4 minus 3. Okay, therefore we have 1 over 2. So 1 over A equals to 1 over 2. When we cross multiply, 2 equals to A, therefore A equals to 2. Or you compare like this. When on top 1 is 1, therefore at the bottom must be the same. So we found A equals to 2. All right. So you watch the next video for part 2. All right. And see you in the next video.